Hello, maurieo. Maurieo converts links to meters. In this video, I'm going to convert some old units, links, chains, acres, roods and perches, to metric units, and in particular meters and meters squared. So let's get on with that and see what we can come up with. So first of all, we'll get out of here and we'll just bring up, I'm going to draw a little copy of the plan in AutoCAD as we go along, and I'm just going to bring up this little worksheet here, worksheet 019, and in this worksheet what I'm requiring people to do is to refer to the portion of DPS 11716 and to draw up a plan of lot 13 with all of the bearings and distances converted to links and meters and the area into square meters. But before we go too much further with that, it might pay just to have a bit of a look at DPS 11716. Here it is, Control 0. So this is the plan here, dated 1967. It's a survey by Rex Hollinger from Hamilton. I used to work for Rex in the early days, 1987, 88, around then. Real gentleman. Now, what we have here is it's a subdivision of a piece of land into some 21 lots by the look of it, 21 residential lots and one roading lot. Now let's perhaps just have a little bit of a zoom in and have a look at a few things. So here's lot 13 up here. Now what does all this mean? Well, the red lines, they represent lines or traverse lines between the little dots which are survey marks, and they represent lines that have been observed. So they've looked along there and measured the bearing with the theodolite, and they've measured along there and measured the distance in links. So they've been observed and measured. The marks, the filled in ones, are old marks from old surveys. So we can see here that this one here is OIS DPS 7172, and that predates obviously the one we're on, which is 1176. So they're old marks from previous surveys. Single ones, generally iron spikes, not quite as permanent or robust as these double circle ones, which are iron tubes, and they're sometimes referred to as permanent reference marks, but more permanent. This one here would be behind the curb. This one's actually in someone's backyard, and you can see how they've traversed along, measured from there to there. A traverse is a sort of a closed circuit, so we can make sure that the circuit closes and use that to check our calculations. Now, going into here, obviously the blue means observed, and their bearings in degrees and minutes, or degrees, minutes and seconds. The red line are distances, and they're in links. But what are the black? What of the black numbers? Well, the black numbers are calculated numbers, so they have been calculated, not measured. Because you see, if we've got a fence on the boundary, it's not possible to measure along the boundary. If it's say a hedge or a post and wire fence or something like that. So what we do is we calculate. Now, say for instance this boundary here, we can start at this peg, a little red circle, a new peg here. We can go from there. We can calculate from there to there, and from there to there, and from there to there, and then we can work out what's missing, or the missing line, or the join between those 2 points. This is an old peg from an old survey here, so we can calculate these boundary bearings and distances. So there the calculated boundary bearings and distances. Bearings are angles measured from north. So here we've got 24, 44, 50. So if we said north is up the page, which it generally is, that angle there, 24, 44, 50, the angle from north. Here we've got an angle 311 degrees, 1940. North's up here. The angle is from north all the way around here, like so. 311, 1940. But we can also just measure this angle in here, which would obviously be 180 less. So that would be 131, 1940. So they do have direction as well. So I think that's all I want to say. These are coloured plans, imperial coloured plans. They stopped making these in around about 1972, where they went to what we call a black and white plan, and that had used distances were in meters. And then we've subsequently gone to digital plans, which were tended to be black and white, and now we've gone into the electronic, totally online plans. They're actually drawn online, live in the database. So things have progressed considerably from here with these plans. So let's now go and have a look at the actual one here. Now I've asked that you do lot 13, so there's little point in me doing that myself. So by way of an example, I thought I would try and maybe have a look at lot 11, given that it's quite simple, and I can draw that up. So I'm going to first of all start with this one here, which is 108 degrees 15 and 190.31. Now what I'm going to do is I'm actually going to draw it up, but I'll do the conversion first. So it's links. 100 links is a chain. A chain is 22 yards. A yard is approximately a metre, and it's like a pace, 22 yards. A yard is 3 feet, so it's 66 feet to the chain. A foot is round about the length of your school ruler, 0.3, and that's 12 inches. And then once we go down below inches, it's fractions of an inch. So that's quite a different system, a system that's still used in some parts of the United States, possibly some parts of Britain where things are measured in feet and inches. Okay, so let's get our calculator out, I think, and I'm just going to do a little conversion there of 190.31. So well, first of all, clear 190.31. So that's our links, and to convert that to meters, we multiply that by 0.201168 equals. And I've got this fixed at there, so I've gone mode, shift setup, and I've gone 6 for fix, and I've fixed it at 3 decimal places. Okay, so we've got 38.284. So now we want to sort of start to draw that up. So I'm going to open up a file. So open file, just a new file. Okay, open files. Oops. Yeah. Oh, no. Well, that's not what I wanted. That's for existing files. So let's just start drawing. Oh, how stupid. Okay, so here we've got a drawing. Now we have to do a little bit of setup before we do that, just to get it all set up correctly. So what I'm going to do is go to the full one here. So I've got all the things. I'm going to open that. Now the first thing I'm going to do is set my units. I need to tell it what units I'm working in. So I just push units like that, and there it is, there, all set up. So I want decimal. I'll go with just 3 decimal places. Now I work in meters for surveying. In some cases, you know, for housing and small mechanical objects, you might work in millimeters. And the AutoCAD is designed to go in millimeters, so you've got to be careful. The angle, I'm going to go degrees, minutes and seconds. I'm going to go to the nearest second. I'm going to go clockwise, and I'm going to go clockwise from north. Okay, and that's the units all set up. Now the other thing that I need to do is I need to sort of tell it what sort of text I want to do, and set up my text. Now I'm going to go with what we call an annotative text, and there's one, I've got one set up here, so there's my annotative text. That's what I'm going to go for. I'm going to click this little arrow here, and that's my annotative text. Now I'm going to go with it to be 2 millimeters high in what we call paper space. So I want, when I print it out, I want it to be 2 millimeters high, or that's my default setting. So I'm going to go close like that. Now this little one that I'm going to draw at the moment, I'm going to draw it at, I'm going to put it in at 2 to 1. So that's 2 millimeters equal meter. It's going to be 1 to 500. I've just got that all set up like that, and then I'll drop back here. Now what I want to do is draw up lot 11. So 108 degrees 15. So we go to the single line like that there, and I'm just going to start anywhere, it doesn't really matter. Now I need to go control chevron, and that's not, I need to go control, oops, not working, control, oh, shift chevron, sorry, not control, that was my problem. And then I've done that, and then 108 degrees, D for degrees, and 15 minutes, a little tick like that, and then push enter, and you'll see that it's, no, it hasn't done, it's, I'm going to start again. I'm going to go for line. No, I want to draw, I want to be at home. I was trying to draw text, line like that, sorry. Now then we go shift chevron, shift chevron, that's it there. 108 degrees, 15 minutes, and then we push enter, and you'll see down here it says angle override 108.15. So that means we're all good. And then I'm going to put my distance in 38.284. Enter. And there it is there. I'm going to escape from there. I'm going to push here. I'm going to escape from here as well. I'm just going to push that there, and that's the extents button. Now I'm going to write, while I'm here, I'm just going to go home, or annotate single line. I'm just going to put some text in here. Okay, now while I'm out, so this is going to be 108. Now I hold down the Alt key, ALT, Alt 248. Oops, that didn't work. Alt 248. Alt 253. Oh. Okay, I'll try this again. Single line. (108). Alt 253. I've got some problems, little problems here. Not working, so 108 out 253 is the squared, out 248. Out 248 gives me the little degree symbol, so sometimes need to persevere with that. 15 minutes 0 0 0. So I've just got to edit that. That's what happened. 0 0 seconds. 2 spaces I usually put in. .284 enter. So that gives me my bearing and distance down there now, finally. And you can see here that I've got the rotation of it. Probably better to make that 08, which makes it a little bit more parallel. You could make it exactly if you want. So that's that one there done, and obviously you can get a little bit faster than this. The problem I've got is that my mouse, I've got my mouse under my keyboard, and I keep knocking my mouse as I go through. Okay, so that's that one done, and you'll notice if you click on here, 108.15 in the properties and 38.284. Okay, so let's move on to the next one, which is 102.00. So that's 102 times 0.201168. 201168, and that's 20.519. Okay, now we've got a bearing there, but we can't quite see it. So what I can do is I've got the full version of the plan here somewhere, and so we've got a bearing along there, 20 degrees 39 across there, 20 degrees 39. I should be able to see that. I'll just knock that out of the way. So, oh yeah, 20 degrees 39. Okay, so we'll just put that in here. Alright, so home, we want to draw a line there. Turn on the snaps here, which are these here, which means it snaps onto there. Okay, so that's and then shift several, 20 degrees 39, and then our distance, which we have to go to here, which is 20.519. So back to here, 20.519. Okay. Alright, so now let's put some text on that one there. So let's annotate single line. Just go there like that. So I'll just go 20 out 248, 39 minutes, 00 seconds, double hit, 20.519. Okay, and then we can move that into position like that there. Okay, all right. Okay, now the next one, 110.39, except 110.39 is going, like if that's 110 degrees 39, if we go back 110 degrees 39 to to north, it's that angle in there. But we're here and we want to go back that way. So what we can do is add 180 onto it. So that would make it 290 degrees 39. So we can go line, enter, alpha line, like that there. And I'm going to go 290 degrees 39 minutes, enter. And now we want a distance up there, which is 189.92. So 189.92 times 0.20168 equals 38.206. So 38.206. Okay, all right. Now, so let's put that in the single text, single line text. I'll just put that in here, like so. Okay, so that's 290 degrees 39 minutes 00 seconds and 38.206. Okay, so yep. What's happening here? So connect onto that. Rotation 111, so I think we could go 110 degrees 39. That makes that nice and parallel like that. Okay. Alright, now we've got one last leg to come back into there. Now that should be equal to what's on the plan, otherwise our boundaries don't measure up. So let's just draw a line in there, a line from a line, draw a line like that there, like that there, and then we can click on that line there, and we can see that that's 245.54. But I'll just get my actual plan out here because we can't see it all, although I think I've written it on there. 245.50, and we've got 245.54. That's definitely close enough. And then we've got our distance here, so let's get our calculator back, and our distance is 110, so 110 times 0.20168. 0.20168 equals 122.128. 122.128. And you can see here that we've got 6 millimeters, so that's pretty good. That's acceptable. 6 millimeters and 4 seconds will not be a huge amount. So we'll just type that in there in our text in here. I might just turn those snaps off. It can be a bit of a hindrance sometimes, so let's just put that in there like that. That's pretty parallel there. And then we can go 20 degrees 45.50, 122.128. Okay, and that should be 21 there. So let's make it 20. It should be pretty good. Okay, so that's that all sorted out there. Now the area. Now, okay, so the area is in purchase. Okay, purchase. Right, now there's many ways you can do this. You can look up the conversion factor, but just before we do that, I just want to go up to here, and here you can see that, oh, I wonder if I can get that a little bit smaller. So this is just Google. Type in links to meters conversion. So let's see, and it'll give you a little conversion thing there, and you can just go 110, 110 equals 122.11. Oh, that's not right there. Where's my calculator? 22.128. Oh, yeah, must just fix that. Oops. That didn't not come out so good. 22.128. That's better. Okay, now, so if we go on here, 22.110, so 110, F5, 1, 110, 22.11, 0.20, 1168. Doesn't look right. 100. 20.1. So not quite as accurate as we would like. Like 100. 100 should be clear. 100 times 0.201168. 20.11. 20.12. That's correct. All right. So that's that done. Now the next thing we want to do is convert purchase to square meters. There we go, and that's it there. And then so for that there, lot 11 is 32.2. So that's 118. Let's move that there. 118. Oh, does it again? It doesn't. Moving over a little bit. 118.4299. So I'm going to make that there. Annotate single line. I'm going to put that in here. I'll use the ortho snap. So that's 814. Usually to the nearest square meter, and to the lowest one. So like at 814.7 you'd make it 815, but at 814.6 keep it at 814. 814 meters, and then out 248, no, out 253, gives you the little squared symbol, and that's going in there like that. And just we'll just make that a bit higher, a bit bigger. 814, so there it is there. Okay, turn off this here and move it around a little bit. Okay, like so. So we can get it all drawn up like so. Now, just by way of a check, we can just use one of the things here of a polyline. So if we just go to the home polyline and we turn on the snaps here like that, and click onto these four corners like that, like that. Remember, we've got a, oops, and then C for close. Click onto this here, and you can see that we've got an area there of 815. So that's yeah, pretty good. Remember, there's a little bit of error on that, so the polyline says 815. Okay, so now we'd like to maybe just print this out, so we'll just go to a layout here, and we'll just that's in paper space. We'll just go to here, model space. We'll just unlock this, and we'll just go 2:1, which is what we printed it up at. So there it all is there. If we wanted to print that out, we could just come to here and just go plot, and we could maybe choose an Adobe PDF. Here it is here, PDF, and we'll just go OK, and it'll ask us where we're going to put it. So I'll just put it up on the desktop for now. Here's the desktop. Oops. Here's the desktop. We'll just put it up there for now, and we'll just go save. That's generating a PDF. So, oops, it's taking a little while to do all this, but there you go. Okay, so bringing the PDF back over here. Here we are, we've got it all printed out. And you can put all sorts of other text in there, maybe a north point and things like that if you want to, but that's just enough, and you're doing this for lot 13. So let's just recap here. So we'll get this here. Let's have a look here. Bring this down here. So you were asked to, referring to the portion of DPS 117, draw in the space below. So you would be drawing lot 13, which is going to come up here, across here. It's got a bit of a leg in, and you're going to work out the area just by converting this here. Maybe write lot 13 in, so that converting those perches to meters squared. And then you will also, yeah, and we want to do it in a digital sense, so that's all good. So you could just submit that with this little one here, or you could take a cut and paste a picture of it onto the worksheet here if you're clever enough to do that, and we can work from there. So let's see what we've got here, and we'll just yeah, so that's a little bit of a lengthy video there on how to do the conversions for that particular worksheet. It does take a while to work through, but I think it's quite worthwhile going through that exercise because one, you'll learn a little bit about links and meters and converting things and drawing things up as you go, and maybe come up with some decent workflows of your own. So that's really important, and you learn the particular outcomes of what you've got, and all of this information will be so beneficial to you later on. Just remember that AutoCAD is available for download using your student email address, and that gives you access to a full student version of it, which is a full version of it. The only thing is it's watermarked when you print out that it is a student version. So yep, that's all pretty good there now. I think we'll leave it there. So cheers, see you.